left off yesterday. We talked about the area of the triangle being 48 square units and the base is 16. We obtained that with the given perpendicular height, which in this case is 6 units. Okay, the y-intercept over there is 6. So knowing that the base has a total length of 16 units, and I know that we've got 4 units on the right hand side, it implies that there must be 12 units on the left hand side, which by counting backwards leads us to -12. So then we end up with -12, 0. Okay, so this is the way to determine the value of the x coordinate is -12 by using some logic. 16 is actually 4 plus 12. And I'm now going to demonstrate what we can do instead, which I think will be quite useful if you are comfortable with algebra. So for example, we can call the value of this x coordinate for n, let's call it x and 0. We know that it is 0. So if I want to find the distance between over here 4 versus this value of xn, if I want to find this distance, I will take 4 minus xn, right? Big minus small, without caring whether xn is a positive or negative value. It doesn't matter. If it is a positive value, something that is less than 4 but more than 0, a positive value, we will take 4 minus that number to get the length. But what if it is a negative number? I am still going to be subtracting xn. Okay, so let's see what happens over here. This gives us the distance, which we know that is going to be 16. We are trying to find the value of xn. So subtracting 4 on both sides to get rid of that 4, we end up with 12. So xn has a value of -12. So this method over here, it's just depending on your skill for algebra and logic of forming that first equation. So once you are very comfortable with algebra, it actually makes you a little lazier because you let the algebra take care of everything else. You just need to form the first correct equation. Algebra will take care of everything else. Okay. Next one is the value of m and c. Okay. So knowing that xn, the x coordinate is -12. Let me put that in first. This is -12. We want to find the value of m and of c. C, we've already obtained it to be +6. That is actually the y-intercept. What about the value of m, which is the gradient? So gradient requires us to find out the rise over the run. So m being the gradient, rise over run. So what gradient are we looking for? We are looking for the gradient of the graph on the left, the one that is sloping upwards. So sloping upwards, we know that the gradient is going to be positive. Given what we remember it as rise over run, we need to identify 2 points that we know the coordinates in order to find the rise and the run. And in this case, we only have 2 points. They are our point N and point L. I'm going to remove all these. Rise from the bottom to the top. I'm going to rise from point N upwards. Rise, 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 rise. We don't rise indefinitely. We have to stop somewhere. We stop at where our point L is staying at, which level. So we rise up to this point and we run to the right. How many units up did we rise? We rose 6 units. Okay, it is at level 6. So 6 units up. How many units to the right? 12 units. So mental sums tells us that the gradient is 1/2. Which is 6/12, which is 0.5. So there we have these 2 answers. Just as a practice, they didn't ask for it. What is the gradient of the line, of this line that is sloping down? What is the gradient of this line? So gradient LM. This is a short form of writing it. Gradient of LM, again, it's going to be rise over run. Okay, you have to remember, we rise from the bottom. Always from the bottom. And we have 2 points over here. 1 point, 2 point. Choose the point that is at the bottom, rise up. If you choose to start from L, you can't rise to point M. You cannot. So M, we rise up, up, until this point. We get also 6 units upwards. What about the run? This time we are running to the left-hand side. Left-hand side, positive or negative? It is negative. When you run to the left, it's negative. See, our x-axis tells us that all the values to the right are positive. To the left, negative. So to the left, negative, and we have 4 over -4, which is -3/2. If for some reason you try to do the rise over run and you end up with this answer, 3/2, you have to recognize that this is a positive number. If it is a positive number, the gradient goes up. For my diagram shows me gradient goes down. If gradient goes down, you must have the sense to add in a negative sign by yourself. Okay? Next one, question 3. Mobile phone company offers customers 2 price plans. A, fixed charge for the first 20 minutes. Fixed charge for the first 20 minutes as shown in the graph. So plan A, on our horizontal axis, we have the time. So for the first 20 minutes, so watch from 0 to 20 minutes, you look at the price. Okay, vertical axis, the total cost, it is fixed at $15. No matter how much time you use, as long as it's within the first 20 minutes, it is going to be $15. So that's the situation over here. And after that, the price will go up. For each additional minute, the cost is P dollars. 1 minute will cost P dollars. So the graph has shown, obviously, they are going to make you find out the fixed charge. We've done that already, 15 minutes. And what is the cost? P per minute after the free talk time. So we need to find out. After 1 minute, meaning my 21st minute, how much are they going to charge me? So if you try to find 21 minute, how much? Okay, so this is our 30. This is our 22, going up. 21, small square. So going by this logic, our 21 minute, which is at the half of a small square, 21 minute. So intersect over here, it appears to be 15.5. Okay, if this is 15, then this value is 15.50. It appears to be, don't copy this yet, it appears to be 1 minute costing 50 cents. Looks like it, right? Does it look like it? So would that be our answer? If we do it this way, it looks like 50 cents is our answer. But you have to realize how accurate are you in reading parts of a small square? You know, we've always been saying you can read up to half a small square, nothing less than that. But in this case, is it truly at the center of half a small square? We cannot tell. If we cannot tell, we need to expand it. We need to zoom in, zoom in, zoom in. But we cannot zoom in on our paper during the exam, right? We don't have that sort of precision. That is why we need to look at bigger or longer talk times. Looking at 21 is not good enough. How about we say, okay, let's look at an additional 30 minutes. An additional 10 minutes. Let's look at the extra cost when I use an extra 10 minutes after the first 20 minutes. Okay. The extra cost in this case will be, we need this value. So this is 19. 19 from 15. That is an increase of $4. It is an increase of $4 per extra 20 minutes. Understand logic so far? Sorry, extra 10 minutes. So extra 10 minutes costs you $4. 10 minutes extra costs $4. So 1 minute extra costs 40 cents. Okay, now, are you happy with this value? Is this an improvement over looking at just 1 minute? Yes, right. I think most of you would agree. Because now we look at 10 minutes, we divide it by, we divide that extra $4 by the 10 minutes to give us 1 minute extra 40 cents only. This is better than just looking at 1 minute. So why don't we just extend this all the way? You know, if 10 minutes is better than 1 minute, how about we look at 20 minutes? How about we look at 30 minutes, 40 minutes, 50 minutes, 60 minutes? Even the bigger the triangle is, the more accurate you will be. Because what we are effectively doing is dividing any errors over a larger number of extra time. So that error will become smaller and smaller and smaller the longer the time is. So we want it as big as possible. But of course, we want to choose something that is convenient. No point choosing a big value and, for example, choosing like this point, you know. This point is not very useful. It is in the middle of a square again. Not useful. Choose a value that is easy to read. For example, this, very obviously, they are trying to tell you that, hey, for the extra from 20 to 120, this is our 100 minutes. For the extra 100 minutes, what is the extra time? Extra cost. So it is from 15 all the way until 55. Okay, so from 15 to 55, we have an increase of $40. So 100 minutes extra cost $40. So 1 minute extra cost 40 cents. So it turns out it is the same as our answer if we just look at 10 minutes. But it is not the same if we simply try and find the 21st minute and read off the value. So this is the difference. And the important skill over here is use a big triangle as far as possible. What triangle am I talking about? This triangle. We always try to use a big triangle to calculate the gradient. Next time, when you move on to sec 3. Small triangle may result in inaccuracy. Okay, now plan B has a charge as follows: $20 fixed charge and 25 cents per minute. So how much does it charge for 60 minutes? So you do the substitution yourself, and for 120 minutes. So two coordinates, two sets of ordered pair provided already. 60, 35, 120, 50. So draw a graph to represent these charges. You have to show us plots. So our first plot, because they say it's a fixed charge, this can be our first plot. 20. Then we calculated for the 60th minute, it is going to cost $35. So look out for your 60th minute. This value, one cross over here, and our 120th minute. It's over here. Alright, wrong one. Okay, then join the 3 points and obtain a straight line for plan B. Whenever you have two graphs on the same axis, look out for the intersection point and know its significance. Here we have an intersection point. It tells us that at this time, of about 80 something, the cost is the same. That is the significance of this particular point of intersection. At this particular time of 80 over minutes, both companies are charging the same amount of 40 something dollars. Whereas at any other timing, from 0 until this, okay, within this region, plan A is cheaper. Why is it cheaper? Look at all its corresponding prices, all the corresponding costs for A and of B. A is cheaper before the intersection point. However, plan B meets plan A in terms of cost and time at the 80 something minute. And after that, plan A becomes more expensive than plan B. From here onwards, plan B cheaper. So this portion, plan A cheaper. So this is an important point that we need. So find the difference in the price between two plans for a call of 20 minutes, $10. That is both of their fixed charge, 20 versus 15. Okay. Oh, sorry, 20 minutes. So when you look at this, $15 versus $25. So difference is $10. Next one, part 2, estimate number of calls when they both cost the same. So as mentioned, find the intersection point. So this will be our T value of intersection. So range is given if it is not obvious enough. In this case, we allow from 86 to 88. Next one, question 4. Table of values, standard stuff. Y equals to 1/3. Every time you see the X, change the bracket, -1. You see a X, change the bracket, -1. It is the same for a quadratic equation. For example, you have to plot Y equals to 3x squared minus X, or minus 2x plus 5. When you see this, straight away change all the X into brackets, so that I can do the substitution. And we'll end up with -3, -1, and 1. So without plotting yet, I want you to analyze this graph. Is this sloping up or down? Up or down? Up. How to tell that it's sloping up? Positive what? Which one is the gradient? Coefficient of X is the gradient. That only applies if it is of the form Y equals to mx plus c. Okay, and now we'll show you a case where we don't have it in Y equals mx plus c. So example, Y minus 3x equals to 2. Okay, now this graph for this equation, is it a straight line? Is it a straight line? Yes, yes or no? Yeah, it's a straight line because I can write it as Y equals mx plus c. Question, is it sloping up or down? Sloping up or down? Confirm up. But I see the coefficient of X is negative. Y must move it. Okay, so if for those who are not answering, and you didn't manage to hear what your friends, your classmates have said, this is it. The coefficient of X is -3. You may think that since it is negative, gradient is negative, so it should slope down. But that is not the case. You have to convert it to Y equals to mx plus c. Once it is in a form Y equals to mx plus c, Then we can look at the sign. Okay, and now it is positive. So it slopes up. These two equations, they are equivalent. It is just one way of writing the other. And when we always say the constant term is your y-intercept, the coefficient of x is your gradient. It only applies if it is of the format y equals mx plus c. So how else can we make your life difficult? Many ways. So for example, I could put it like this. So you have to identify what is the value of, what is the y-intercept in this case? Is it 2 or negative 2? 2 or negative 2? So you have to change that in your mind. Y equals to mx plus c. So you need to bring the 2 over. Meaning you add 2 on both sides. You end up with positive 2. So y-intercept is 2. And I can make your life even more difficult. I put a half over here. So you need to realize and understand how to make y the subject. Our y equals mx plus c is simply making y the subject. Okay, so in this case, half y equals to 3x plus 2. Next line, y equals to 6x plus 4. So our gradient increased to 6, y-intercept increased to 4. Because I need the coefficient of y to be 1. The format, y equals mx plus c. So you know that in this case, it is sloping upwards. Gradient 1/3 is positive, and the y-intercept is negative 1. So let's see. Okay, now here we should be looking at this graph. Intercept negative 1, and it is sloping upwards. Pretty gentle slope because the gradient is quite small, 1/3 only. So let me remind you again, for graph drawing, scale, SCALE, 1 mark. So if they say 2 cm to 1 unit on the horizontal axis, 5 cm to, or 2 cm to 5 units on the vertical axis, you follow that, you get 1 mark already without plotting anything. Then you plot in your points. There are 3 points over here. I should see 3 crosses, -6, the -6 point, the 0 and the 6 point. So another point, 1 more point. 3 points, you get another 1 mark. Plot, 1 mark. Graph, 1 mark. So total 3 marks. Very good. Sometimes they may combine these two into 1 mark. They're not as good as you. Okay, next thing to note, you must always write down the equation. So in your work, write down some notes for yourself. Must write equation. You must have the vertical axis, horizontal axis, what they represent. So in this case, y and x. Most of the time, it's going to be y and x. But sometimes it can be h for height, t for time, so on and so forth. Must have. Next, your labeling of the graph, of the axis. This part. Mark out every 2 cm. Don't go beyond that. Meaning, don't go and mark every 4 cm because you're lazy. Wow, you think you can save some time. Every 2 cm, you must mark it out. So that is the same for vertical and horizontal. Every 2 cm, mark it out. Draw another graph, 2y equals to x. So is this graph a straight line? 2y equals to x. To decide, we think, what is the format for a straight line graph? Y equals to? What did you say? For a straight line graph, it's not always y equals 0. Y equals 0 is an example of a straight line, which is our x-axis. This is y equals to 0. Level 0. But what is the format for a straight line in general, we think? Y equals to? Y equals, and good. y equals to mx plus c. And very obviously, currently it's not in the same format, right? What do we need to do to both sides? Aloysius? Divide by what? Okay, good. So we end up with y equals to half x. With this equation, I can now plot. We need 3 points, huh? So another note that you need to make for yourself. We need 3 points to plot. So my table, x and y, then I've got blanks for 3 sets of coordinates. So they mentioned that you have to draw from -6 to 6, -6 to 6. You have to show the endpoints. What will you choose in the middle? You want to make life easy or difficult for yourself? Easy, right? Put 0 lah. So get the table. Y is equals to half of x. So -3, 0, and 3. Show me the 3 plots on the graph. Join. Okay, so now they do intersect. Where do they intersect? At this particular point. It is a common point. So what is the significance? Continue to say that this point satisfies both equations. It is a point that lies on y 2y equals to x as well as y equals to 1/3 x minus 1. And one extra point to note, a point that lies on both lines, we call it solving 2y equals to x and y equals to 1/3 x minus 1 simultaneously. When you solve two equations simultaneously, we are looking for the point of intersection. That point of intersection has x and y coordinates, and they are the solutions for x and y. Okay, final homework question. Anybody needs more time? So now, yes, we see our quadratic graph. Y equals to 2x squared minus 6x minus 8. Write down some notes. Which actually, I think we wrote on the first page, right? First question. So this, in this case, is it a smiley face or a sad face? Smiley face due to the +2. Smiley face. Opening upwards, huh? So we know that there's going to be a minimum point. And then for a parabola opening upwards, there are 3 possibilities that we can have with respect to the x-axis. Either it looks like this, where it intersects twice, or it may look like this, where it intersects once, or it may look like this, where it doesn't intersect at all. These are the 3 possibilities. And then we have a straight line, gradient, 2, so it's sloping up. Intersect, the y-intercept is -14. So they intersect at points P and Q. Write down the coordinates of P and Q. Writing down is not a problem. So P 3 -8, Q 1 -12. Okay, 2 points of intersection over here. So again, you can repeat the same notes that we are writing. Points of intersection on graph when we have 2 graphs on the same axis. 2 graphs on same axis. Find points of intersection. This point or points of intersection will be our solution to simultaneous equation. So in this case, what are the simultaneous equations? We have the first equation highlighted in yellow. The second equation in green. So if I try and solve the 2 of them simultaneously, meaning at the same time, we will end up with these solutions. We have x equals to 3, y equals to -8, or x equals to 1, y equals to -12. Two sets of solution. And B part 1, from the graph, estimate the solutions of the equation. Okay, so this is the other very popular question during exams. Make sure you know how to do it. So first, 2x squared minus 6x minus 8 equals 0. Go back to your graph. What do you already have? Yeah, the one that was yellow, right? We have y equals to 2x squared minus 6x minus 8. Hey, you have this particular graph. They want you to solve when it is equal to 0. When it is equal to 0. When what is equal to 0? 2x squared minus 6x minus 8 equals 0. Meaning y equals to 0. So draw this graph. Draw. Y equals to 0. Find the points of intersection. But do we need to draw y equals to 0? We don't, right? What is y equals to 0 again? Just now we didn't give us. What is y equals to 0? The x in the x-axis. This is y equals to 0. I am trying to find the points of intersection between y equals to 0 as well as the curve. And very obvious time, 2 points over here. They are -1 and 4. The solutions are x equals to -1, x equals to 4. Next one, slightly more tedious. Again, compared with your quadratic graph that you have already drawn. 2x squared minus 6x equals to -4. Currently, kind of look alike, but not exactly. The objective is to manipulate. The equation they want you to solve into what you have already drawn, because you don't want to waste your effort. Anyway, they ask you to from the graph lah. So you have to manipulate this to become like 2x squared minus 6x minus 8. So we did some examples in class. Write down your 2x squared minus 6x equals to -4. Now manipulate it to what you already have drawn. You have drawn 2x squared minus 6x minus 8. In the equation you need to solve, you don't have -8. Okay? See that? You don't have the -8. I want it to look like the graph I already have. So I put in -8 up. And now it looks like what I already have drawn, at least on the left-hand side. But the logic tells me that, hey, if 2x squared minus 6x is equal to -4, then I choose to put in that -8 on the left-hand side. They are no longer equal. In order to make them equal, I must do the same for the other side. This brings us to the next step. We have 2x squared minus 6x minus 8 equals to -12. And then I look back again. Hey, now they are the same. 2x squared minus 6x minus 8. 2x squared minus 6x minus 8. I have drawn the graph of y equals to 2x squared minus 6x minus 8. I have drawn that already. And because I included that y equals to, the same can be said for this graph that is highlighted, that is outlined. I need to draw y equals to -12. And I find the points of intersection. So where is the line y equals to -12? Y refers to level. Level -12. Take the lift down to basement, -12. So this being -10 is over here. So this horizontal line, y equals to -12. Label it because there are a few lines that you're drawing. Make sure the marker knows what you're drawing. So drawing the line y equals to -12, you search for the points of intersection again with the curve. it appears to intersect very nicely at point Q as well as this other point. So whatever the x coordinates are will be the solution. So in this case, x equals to 4. No. Next one. Yeah, the other one. 1 or 2, is it? Yeah. According to the graph, 1 or 2. By drawing the line y equals to -12, we find that the x values are 1 or 2. This is the solution. So I hope you are learning something. But it's also dangerous to learn things halfway. What do I mean by that? I think generally you have an idea of what we are looking out for the solutions, of what to draw, what to find, points of intersection. But if your memory, if your knowledge is incomplete, you may think that over here, find points of intersection. And then look at these 2 points. Point Q, it has x coordinate of 1, y coordinate of -12. 1, -12. The other point of intersection is 2, -12. So if you remember part of today's lesson, find the point of intersection. 1, -12, 2, -12. You go back to the question, you say my answer. Is it? Then in B part 2, answer. Over here, this would be worth at least 2 marks. You write down 1, -12, 2, -12, you get 0. Okay? Because they said, they ask you to find the solution to the equation. What is the equation? This is the equation. The equation doesn't have y. The equation only has x. When I ask you to solve for equation, solve for x, you will tell me x only, isn't it? You won't tell me y, because it is irrelevant. In fact, it may not even exist. If we just look at this, 2x squared minus 6x equal to -4. Solve. Nobody will tell me that there is a y value. Based on that, it is simply just x values only. So you cannot be writing the y values. The 2 answers are x equals to 1 or x equals to 2. So you have to know what you're doing. It's not just about the points of intersection. Then finally, draw the line of symmetry and state its equation. Line of symmetry, very obvious. One vertical line, top to bottom. But exactly where is the bottom? We know exactly where is the middle. We know that lines of symmetry, this is another set of notes, another point that you should write down. Lines of symmetry pass through turning points. Source familiar. I think I wrote it earlier on. Line of symmetry will pass through a turning point. Are you confident that you're able to identify where the turning point is? If you are, now draw a vertical line through it. If you are not confident, find the points of intersection. So in this case, -1 and 4. Find the center of -1 and 4. So what is the average? 4 plus -1 over 2. So that is 3 over 2, 1.5. Mark it out exactly 1.5, draw a vertical line. That is our line of symmetry. Next is to state its equation. State its equation. The equation must have left hand side, must have right hand side, must have equal sign. X equals to 1.5, 3 over 2. Without the x equals 2, you may have done the calculation. Wow, 4 minus 1 over 2, you get 3 over 2. You come out of your exam telling your friend, hey, here's your equation, it's a line of symmetry, 3 over 2. your friend, yeah, 3 over 2. Everybody very happy. End up all wrong. Because never write x equals 2. Why must write x equals 2? Because it stays in an equation. 3 over 2 is just a number. X equals to 3 over 2 is an equation. It becomes a line. So I think this is it for our homework questions. So now the remaining time, please carry on with the rest of this set. We've got 2 more questions, 6 and 7.